Hey everyone, welcome back. Today we're diving into one of the biggest questions in cosmology. Is the universe infinite, or is it just really, really big? At first, it seems like a simple question. The universe is undeniably vast. So vast that even light, traveling at an incredible 300,000 kilometers per second, takes billions of years to traverse it. But does it go on forever? Or is there some kind of boundary? A cosmic edge where space just stops? Before we try to answer this, we need to clarify something. What do we actually mean when we say infinite universe? What do we mean by infinite? Infinity is a strange concept. In everyday life, we don't encounter true infinity. Everything we experience has limits. Even the vast ocean has shores, and even the tallest mountains eventually reach their peaks. But when it comes to the cosmos, things get weird. An infinite universe would mean that space goes on forever. No boundaries, no edges, no stopping point. And if that's the case, it also means an infinite number of galaxies, stars, and planets. Maybe even infinite versions of you, me, and everything that has ever existed. But infinity isn't the only possibility. The universe could also be finite but unbounded, meaning it has a definite size but no actual edges. A good analogy is the surface of a sphere. If you keep walking in one direction on Earth, you'll never hit an edge. You'll just keep looping around. Could our three-dimensional space work the same way? To explore these possibilities, we first need to understand a crucial concept: the observable universe. When we talk about the size of the universe, we're usually referring to the observable universe. This is the region of space that we can see, a sphere about 93 billion light-years across. But wait a second. The universe is only 13.8 billion years old. So how can we see things farther than 13.8 billion light-years away? The answer lies in the expansion of space. Since the Big Bang, space itself has been stretching, carrying galaxies away from each other. The farther something is, the faster it moves away. This means that light from the earliest galaxies has been traveling for billions of years, but in that time, the galaxies themselves have moved much farther away than their original light travel distance. This is why the observable universe is so much bigger than 13.8 billion light-years. But, and this is key, the observable universe is not the entire universe. It's just the part we can see. There could be infinitely more beyond our cosmic horizon, or not. So, is the universe infinite? Scientists consider three main possibilities. 1. The universe is truly infinite. In this case, space extends forever in all directions. No matter how far you travel, you'll never reach an edge, because there isn't one. This would mean an infinite number of galaxies, stars, and planets. Maybe even infinite copies of you and me too. The universe is finite but unbounded. This means the universe is really big, but it loops back on itself in a higher dimensional way, like the surface of a sphere, but in three-dimensional space. If this is true, traveling far enough in one direction might eventually bring you back to where you started. 3. The universe is finite and has an edge. This is the least likely scenario, but some speculative models suggest the universe could have a boundary. Not necessarily a physical wall, but something governed by physics itself. So, which of these is correct? Right now, our best evidence suggests the universe is geometrically flat, or very close to it. Cosmologists measure this using the cosmic microwave background, the afterglow of the Big Bang. Tiny fluctuations in this radiation give clues about the overall shape of the universe. If space were strongly curved like a sphere, we'd expect certain distortions in the cosmic microwave background. But current measurements show that space is very, very flat, at least within the observable universe. Why does this matter? Because in Einstein's theory of general relativity, the shape of the universe is linked to its size. A perfectly flat universe could be infinite, but it could also be finite and just extremely large, so large that any curvature is too subtle for us to detect. Could we ever prove the universe is infinite? Here's the challenge: we can't see beyond the observable universe, and we probably never will. The expansion of space means that distant galaxies are moving away from us faster than light, meaning their light will never reach us. So if the universe has an edge, or if it loops back on itself, it could be beyond our cosmic horizon, forever hidden from view. But there are ways we might get hints. 1. Measuring cosmic geometry more precisely. Future telescopes could give even more precise measurements of the cosmic microwave background. If we detect even the slightest curvature, it could suggest a finite universe. 2. Looking for repeating patterns. If space loops back on itself, we might see repeating patterns in the arrangement of galaxies or cosmic radiation. So far, no such patterns have been found. 3. Theoretical models and simulations. Scientists are constantly refining mathematical models of the universe's structure. If they find strong evidence for an infinite or finite universe in their equations, it could give us more confidence in one answer over the other. Does an infinite universe mean infinite copies of you? Here's where things get weird. If the universe is infinite, then everything that can happen must happen an infinite number of times. That means somewhere, beyond our observable universe, there could be an exact copy of Earth, with a person just like you watching this video. And not just one copy, an infinite number of them. This idea comes from probability. With infinite space and a finite number of ways to arrange matter, eventually, identical patterns must repeat. But of course, this is just speculation. Until we can find a way to test it, it remains one of the many mysteries of cosmology. So, is the universe infinite, or just really big? Right now, we don't know for sure. The observable universe is enormous, but we have no direct way to see beyond it. If the universe is perfectly flat, it might be infinite. If it has even a slight curve, it's probably finite. Right now, the best answer we have is, we don't know, but the evidence leans toward it being either infinite or so large that we may never reach its limits. What do you think? Could space go on forever? Or is there a cosmic boundary waiting to be discovered? Let me know in the comments. And if you enjoyed this deep dive into the cosmos, don't forget to like, subscribe, and hit the notification bell for more mind-blowing content. See you next time.